Hello. Welcome to another session for CircleCityCon. I love this year's theme, so I am a happy little avatar for a happy little conference. Well, this is going to be a shock to the system, real static analysis for real AppSec. My slide deck and everything, and I do mean everything I talk about in references to the tech that I reference in this talk, is available at tinysi/static. So, who am I and what do I do? My name is Ochaun Marshall. I code, I teach, I hack. I am a full-time developer, full-time cybersecurity consultant / penetration tester, and when I'm not doing either of those things, I'm teaching you how to take over the world. This is not a security talk. This is more of a developer talk. This comes from not only being a red teamer, but also having to also be a dev with deadlines and have to work in CI/CD pipeline. So, without further ado, let's get started. The 3 points that we're going to talk about in this talk is TTP, tools, techniques, and people of a static analysis engagement. Now, I know what you're thinking. I thought this was a technical thought. How dare you infiltrate your thought leadership? But understand and know that if you ignore the human element, you aren't going to get anywhere, especially when we're diving into source code and working with development teams. So this is not the traditional use of TTP, but every element here is essential. For the uninitiated, static analysis is the process of examining software code without execution. The whole point is to see what information we can grab or glean from just looking at the source code itself. Now, what bugs can we find that actually compromise confidentiality, integrity, or availability? And there are many things that can lie to you, but code can't. Now, a pen test is wonderful. A pen test is beautiful. I say that as a pen tester. There are no false positives on a pen test. However, this is a big however, pen tests are expensive. And not everyone has and maybe you can get a pen test once a year, maybe once a quarter, maybe monthly. But you're not pen testing constantly as new code is added, new features. Chances are you're going to add dozens of features before your next pen test comes around in that cycle. So here we can actually, with static analysis, we can actually insert into our pipelines and take a deep dive into security flaws that may be present within the code. And the wonderful thing about this is now we've got infrastructure as code. So not only do you have the actual application ready, but you also can have the entire infrastructure, cloud infrastructure that is going to be deployed tied into the same product. It's turtles all the way down, and it always was. So quick story time before we begin. Here's how a usual static analysis engagement goes. The sec people get around, we all commiserate together. There may not be a developer in the room. The closest thing we'll get there is a project manager, and this is from the client side. And we commiserate, and CISO loves us. They say, okay, let's whip the devs into shape. And so right then and there, some red flags appearing, but okay. We do our best in that engagement. We ask the right questions, and then we generate a report, which is useful. It's helpful for that little brief time, but it doesn't age well. In the next, what if you fix all of the bugs that we generate with the report? Are you really going to wait until the next report? There's a better way to integrate static analysis into your AppSec program. Now, your first instinct when you're diving into this endeavor is grab all the things, buy all the tools. However, you must be calm. You must be tranquil. Think what sparks joy. Minimalism. Minimalism is key. So, first of all, do you know what language or languages the application is written in, or apps that we're testing? Are you aware of the technology stack that surrounds it? The tools we pick and the tools we bring to the table have to come from, have to be useful to actually deriving information from the application that we're testing. Noise reduction is especially important. If you've got a whole bunch of tools, that you'll get a whole bunch of false positives, and you have to go through a lot of false positives because there are going to be either two things wrong. One, your dev team has written a horribly vulnerable app, or two, your tool isn't configured correctly. And the only way you can get there is actually by diving in and trying to understand context within it, and also configuration to the tool so it doesn't blare off on the wrong thing. But one thing that stack analysis is really good for is analyzing the software supply chain. Because if you spend thousands, and I'm talking thousands of dollars on a pen test, and it's news to you, it's brand new, the fact that you've got missing patches, you are wasting your time and money. That's because your pen test, your quarterly, monthly, yearly pen test, should never be the first place you find out that you have missing patches. Also, manual patching is a waste of time. If you can automate it, do so. And also, when you're starting out and you're building a project, avoid deprecated and end-of-life software. I know that's harder than it seems, especially with like Jthon, for example, the Java Python library. Yeah, the Java Python library that's still running 2.x. And also the fact that if you have a Node library running and you may have written a Node app within the past 5 years, you have to check your dependency to find out if you're using the request library, because the request library is entering maintenance mode and will eventually be deprecated. So I'm going to go into a brief demo. This is to cover the workflow of an analyst. So if you're a consultant called on the job, if you're the one security champion who's voluntold to do all of these things, this is useful for you. I'm going to see, and for those of you who download the slide deck later, there's a little treat. We've got music and all that. I'm going to try to mute that because I'm not sure of the audio setup here. So right here, I expect you all to know how to clone a repository. The links to it is stack analysis TTP. It's open source, and so this is just a Vagrant box that we'll spin up. So first thing is first, I flounder CD into the directory, of course, and then I edit the Vagrant file. This is important. You can configure different things for the VM, same way as if you're using VirtualBox GUI. The settings here will actually overwrite the settings that you will have in VirtualBox. What I'm adding here is just a synced folder. That way that the client code stays in my host and I'm just doing the analysis in the Vagrant box. And then I just output the analysis into that same folder. And we will skip, because that's another reason. To actually spin up the Vagrant box, we just do a Vagrant up. I'm going to skip some things. Trust me, I've done this demo live before. It's 10 minutes, and 10 minutes is maybe quick for you guys, but on the stage, it's absolute agony. So we're gonna fast forward, and then from there, it's just Vagrant SSH to actually get into the box. Now, there are a couple of typos that I do. Skip those to get to the juicy part, and that is we're exiting out, and I'm going to provision SonarCube. The tools that I mentioned in the previous slide, like Bandit, Sonar, not just SonarCube as well, but also Shell Check and other things are actually provisioned into the Vagrant box. So with different provisioning scripts, you can actually customize it based on the application or what client and their needs. Here, we've also got some scripts to create the Docker, Docker image? Yes, Docker image. And then start it. The IP addresses are local to your machine, so you can connect to them from the host. So this window, I'm actually pulling from the host machine, copy the IP address, pull from the host machine, and we're just running, SonarCube. This is a fresh trial install. And the beautiful thing about this is that you could actually save the analysis from the tooling here by just exporting the Vagrant image. So if you can't, for the example, the trial version of SonarCube won't let you export reports. You can just ship the machine into your internal evidence systems. So the Vagrant box, of course, is Linux. This is your standard SonarCube run. I think the app in this case is Python. Use Python. Yes. Yep. And I found some vulnerable library on the internet, and then I just run the quick analysis. And that's not fast forwarding, that's actually real time. So a lot of, depending on how much of your system resources that you allow to your Vagrant image is how quickly it can go. Right now, it's a simple example. It's one security hotspot, and we've got hard-coded credentials. Now, normally you would dive in, investigate, see, is this really a false positive? But since they go through the effort of hashing that hard-coded string, I'm going to assume that this is indeed what it says it is. So now we move to the second part, technique. So we let engineers, if you let your engineers actually look in the code, they're going to find things that you're not going to find. And this beautiful image is a wonderful example. I would not see this. And now that I do, C-SPAN will never be the same again. It's the same way as when you train up your developers and your engineers. They will see flaws that you didn't even think about. And for them, it's not just a checklist. It's a design flaw into something that they built. So my advice to you is, if you're a consulting company or you're working with your internal resources, assign someone who has written production code within the past decade, please. That actually helps to find real design flaws. Another thing that we need to understand is it's okay if some things are manual at first. Anything that relevant to IT, there is an XKCD for it. I love this image because this is my life. This is an autobiography. And so we spend there's so much time wasted in automation that it would have been simpler just to do the tasks. So understand that automation is great, it's fantastic, but it only works if you absolutely have a deep understanding of what it is you're automating. The reason why you would use something like CloudFormation is because you're automating the task of manually going into the console of AWS and then changing the configuration settings for different resources. Unless you know what your audit, if you just jump straight into CloudFormation or Terraform, not knowing what everything is, it's actually going to be difficult because the infrastructure as code is just JSON. And it's just JSON of the configuration settings that you would find in the console. So I'm going to do demo with some automation because the manual steps we already have known and ingrained with ourselves to the point that it is good enough to add that automation. Before we do, also want to remind you all to integrate your static analysis that you put into the pipeline in with all of your existing security methodologies. For example, this 4-step methodology is what we use at Secure Ideas. And it's beautiful because as part of Recon, you could have a full white box engagement where you have one consultant working on the static analysis, diving into reports and finding code execution flaws, and you could have another analyst actually performing the pen test dynamically, and it's beautiful. You'll be interested in what we find. I think CVEs get found this way. So if you don't have that full white box assessment going on and it's just a straight up static analysis, you just got to break up that whole recon of being more 20%, 30%, 35% would be mapping your application. So traversing through the code base, seeing where everything fits together. And then 35% vulnerability discovery. Once you've done the scans, the vulnerabilities pop out at you. The possible vulnerabilities pop out at you, and they're already discovered. And then the 10% is the exploitation. So we're going to do a brief demo on just the CI/CD pipeline. We're doing the video for a different reason than the other reason. The demos for this is actually quite short, and this pipeline runs in minutes. However, I love you all, but I don't trust you. Having it pre-recorded lets me censor some PII and sensitive information. So let's get in. So we've got pipeline, and we notice that the build failed. So we dive in and we see that we're running Yarn Audit. Now Yarn Audit is wonderful. It allows you to see all these vulnerabilities in the code. Not necessarily in the code, but also in the software supply chain, your dependencies. I don't know about you, but my boss is a killer with the code review and will not let me ship code with cross-site scripting in it. However, this demo is incomplete. It's incomplete because because although we've demonstrated that we can block access, I think Alyssa Miller once said that developers don't want gatekeepers, they want functional code. And I agree. My boss also would like functional code and functional pipeline. So this is screenshots of the pipeline actually working and how we've opened it up so that we get the same security checking. Well, here you can set the audit levels on Yarn Audit to high, and you can also set it to tac dependencies. And so that way you don't focus in on vulnerable dev dependencies that don't actually ship to client, don't actually get shipped in your client-side code. You can actually make it even more granular. So you don't stop the build, and you also don't have to stop the build. You can hook alert scripts into you can hook up alert scripts on a high triggered thing. So If the pipeline has to be available 24/7, zero downtime, then maybe change the configuration settings so that you get alerted rather than blocking the pipeline. Another thing that's really useful is for CloudFormation stacks and CloudFormation templates is CFNAG. Now, CFNAG is just this good linter, and also CFN lint, which AWS uses. That is also useful for examining for security flaws within the IAM policy. This is useful for when I dive in, for when I have to do IAM as part of the CloudFormation template. And I link to the at least CFN NAG, but you can ping me later and I can point you in the direction of CFN lint. And now we go to a vision for you. Our organizations have deteriorated to the point that every time a thought leader again walks on stage and points out that cooperation leads to better business outcomes, we hail them as the innovator of the 21st century. And you may ask, well, okay, what is your solution to the people problem within the static analysis engagement? And I'm like, dude, I'm 26. I bust holes in walls and write code. But I do see from our clients that are performing well in their application security program versus clients that are not doing well in application security program. And the way they start, the way that the professionals do it, is they start with asking the right questions. So whether you're part of an internal security team or you're stepping on to a fresh static analysis engagement, and this is the first time that you're working with a client, here are some questions that you need to ask. 1, what is this app supposed to do? You'd be surprised on how many people miss that very simple question. Then you have to figure out what are the standard use cases. So this thing was built for a purpose. So what's the happy path here? And then you can drill down into the security questions, like what should a user be able to do? What should an admin be able to do? Again, from questions from beginning of the talk, what infrastructure is surrounding it? You can save yourself so much time while you're fuzzing if you ask them, hey, are you using a SQL database? No, it's a NoSQL. Use DynamoDB. Wow. So I don't have to waste execution time pushing SQLi payloads in the request. It's not going to do anything. Second thing is this obsession that we have with compliance. There are a lot of security teams that are just starting. Usually it's just one guy on board and they're just trying to get everyone to comply with all the things. But the focus really needs to be cooperation. You will get compliance. You will get compliance eventually if you've got teams communicating with each other and collaborating with each other. Not just cooperation, but collaboration. If you have that, then the compliance thing it literally is a checkbox, because it's in that you don't have to do anything new. The security team is aware of the new technology that the development is spinning up in the environment. And I don't bring static analysis to the table to raise another holy war between security teams and devs. It doesn't matter if you're a traditional DevOps person or you have dev and ops as separate teams. The point is, those things are functionally equivalent if you've got collaboration with the group. So 1, bring engineers to the table. for the kickoff call, you can find some senior engineer. His life is consumed with meetings anyway. He's not actually writing code. So you can bring him in when we're actually doing the static analysis, or even when we're doing the pen tests, to start to explain the use cases for the product. Then you can begin the conversation and the genuine collaboration between security, dev, and ops. And this is what Agile was all about. This was what DevOps was supposed to be for anyway. And in the olden days, the thought leaders called it synergy. And so that brings us to the end of the talk. The three things that you need to focus on to really defibrillate and bring life back into an AppSec program through static analysis is: one, remove waste. Find tooling that is designed to give you insight into your technology stack. Then you bring the engineers to the table and we do detailed analysis of the source code. We automate what we already know how to do, and then we also associate that existing tooling and processes with the more traditional parts of security, like dynamic analysis, DAS tools, as well as pen tests. And then finally, just stay curious and collaborate. Ask the right questions. And you have to understand that this is not just a journey for the 1 or 2 or 5 or 200 security people, and that it's a collaborative journey for everyone together in the organization. Stack analysis. Put a shock to your system.